The real positive root of the equation 7x cubed plus 19x squared minus 3x minus 20, it is equals to 0 in the interval 0 and 1. Obtain the root of the equation using the second method at the what? At the fifth iteration. So we have to first write down the second method iteration formula, which says the x of what? N plus 1. It is the same thing as s of n minus f of x of n multiplied by x of n minus x of n minus 1 divided by f of what? F of xn minus f of xn minus 1. So you have to take note of the formula, and I have to define my function. I'll say f of x will be 7x cubed plus 19 what? 19x squared minus 3x minus 20. So this is a function. So therefore I'm going to choose x0 to be 0 and x1 to be 1. So for f of 0, it will now become f of what? F of 0 raised to the power of 3 plus 19 of what? 0 squared minus 3 multiplied by 0 minus 20. At the end I will get negative 20. So this negative 20 is for this function of what? Function of 0, which is f of 0. So therefore the function of what? Of 1, which is f of 1, if I insert 1, what should I going to get? So I'll have plus 19, I'll have 1 squared minus 3 multiplied by 1 minus what? Minus 20. It will now become, so I'll get 30. So therefore the function of 1, it is what? It is 30. So you have to take note of that. So the next thing that I'm going to do, I'm going to first find the first iteration. The first iteration at n, it is equals to 1. So I have to say x2, it is the same thing as x1, because the formula says x of n plus 1. So I said when n it is equals to 1, so when n it is equals to 1, this will now become 2, and n it is equals to 1. According to the formula, this place is n, so I have to replace it as what? As 1. So therefore minus f of what? F of x1, which is x0 x1 minus x of 0. In here, and from the formula, we have n minus 1. So you have to take note that n it is 1, and I have to say 1 minus 1, and it will be 0. So x of what? X of 0. So I'll say f of what? F of x1 minus what? Minus f of what? F of x0, which is for the first iteration. So the next thing that I'm going to do, I have to first substitute what will be the value of x1. x1, it is what? It is 1. So I have to say minus f of x. So the solution that we find for f of x1, it is what? It is 3. That's for the f of when we substitute the value of x for 1, we got 3. So I have to say the x1 from the question that I said. The question, it gives us the interval of 1 and 0. So therefore I said x of 0, it will be 0, and x of 1 will be equals to 1. So this x of 1 and x of 0, 1 will be 1 and 1 will be 0. So I will now say multiplied by 1 minus 0 divided by the function of f of x1 and minus f of x0. So this is the same thing as saying the 3. The solution of f when x it is equals to 1, I have to say minus for the solution of x when we insert 0 in the function of what? In the function that we define, we got negative 20. So I have to say minus 20. So therefore at the end, x2 should now be equals to, if I said 1 minus 3 multiplied by, you have to take note that this is multiplication. 1 divided by 3 plus 20. So therefore at the end I have what? I have 0.86956 So this is the value of what? This is the value of x2. So I'm going to find the function of x2 itself. So what will be the function of what? The function of x2, it is the same thing as saying the function of this answer, 0.8695 9565. So I'm going to substitute. I'll say 7. Instead of putting x, so I'll put this value. So let me just say the value of x2. So this is the value of the x2. So I will say to the third power plus what? Plus 19. So as you can see, you are going to substitute the value of what? Of this x2 in this x2, x2, and what? And this x2. So therefore, the next thing that I'm going to do, I have to calculate it. I have to say 7 multiplied by 0.89565 cube root, and also 19 find that x2. So therefore, I'll get negative 3.6330 what? 5. So I have to perform my second what? My second iteration. Second iteration, when x it is equals to, when n it is equals to 2. So from the formula at the subscript, which is n plus 1, because n is 2, so I have to add it with 1, so I'll get x of what? X of 3. So this should now be the x of 3 should now become, I'll have x2, this will increase, and I'll say minus f of what? X2, and therefore x2 minus what? Minus x1 divided by f of x2, and also minus f of what? F of x1. So I have to substitute. So therefore I will now say the value of what? Of this x3 should now be equals to, what will be the x2? Our new x2 will be 0.8. As usual, we already find the value of what? Of our x2, 95665. So I have to subtract it by what? By the function of x2, which is negative 3.6, and then I have to multiply by this x2 minus x1. So the value of x2 I will multiply by 0. Again, value of x2, which is 69565 minus 1. So then I have to divide it by x2, f of x2 minus f of x1. So this will now be negative divided by negative 3.635 minus what? Minus 3. So at the end, my new x3 should now be equals to what? Let me say 0.6. So at the end, my new x3 should now be equals to 0.9409665. So I'm going to find the function of what? Function of x3 by inserting the value of the function and substituting in what? In this equation. So therefore, this is the same thing as saying 7 multiplied by what? Multiplied by the x3 raised to the power of 3, and also plus what? Plus 19 x what? X3 squared, and also minus 3 x3 minus 20. So let me see, what should I going to get? So this will now be equals to negative 0.1749. So this is a new function of what? Function of x3, and this is what? This is the actual x3. So now I'm moving to what? I'm moving to the third iteration. Let me say this is third iteration when n it is equals to 3. So this will now become x of 4 minus the function which is f of 3, and therefore multiply by x of 3 minus what? Minus x2 divided by what? Divided by the function of x of what? Of 2. So this will now be equals to, what will be our x3? If you could remember, the value of the x3 that we find, it is 0.965. Then I have to subtract it by the function of what? X of 3, which is this 0.179. So I will now say, but I have to delete this, but you have to take note of it. So which is negative 0.1749, and also I have to say multiplied by this x3 minus x2, which is 0.9406 I think 0.94065 subtract by 0.89896 what 65 divided by what, divided by f of x3 minus f of x2. So f of x3, it is negative 0.1749, which is what we find here, and therefore minus the f of x2, which is negative 3.3335. so we have minus and minus here. So at the end, what should I going to get? So therefore the next thing that I'm going to do, this will now be equals to, I'll have 0.94465 as what, as my x4. So the next thing that I'm going to do, I'm going to find again the function of what, the function of x4. So therefore the function of what, the function of this x4, it is the same thing as the 0.94456 whereby I will say this is the same thing as x of 4 raised to the power of what, of 3, and also plus 19 of what, of x of 4 squared minus 3 x of what, of 4 minus 20. So the next thing that I'm going to do is that I'm going to substitute this x4 as what, as this value. So at the end it will be 0.017. so therefore the next thing that I'm going to do, I have to go through to what, through the fourth iteration at n it is equals to 4. So therefore it will increase, it will now become x of 5, it is the same thing as x of 4 minus what, minus the function x of 4, and also which is x of 4 minus x of what, of 3, and f of x 4 minus the function of x of what, x of 3 also. So now I'm going to substitute. So at the end this will now be equals to the x of 4, it is the same thing as what we find 944,565, and I'm going to subtract by what, by the function which is 0.0117, and therefore I'm going to say the x4 the same thing as 0.94465 minus the x3, if you could remember, 0.94096 divided by f of x4 and f of x3, which is the function 0.017, and therefore I have to subtract it by minus 0.1749. So what should I going to get? .4. So therefore this is the same thing as 0.944265. So therefore, as you can see, the real positive root at the fifth iteration is approximately 0.9443. So this is the fifth iteration that we are asked to find. Find the polynomial f of x from the given data summarized in the table. So we are given this table, and hence we are to find the f of 4 from the obtained polynomials and compare to the table. So we have x, we have 0, and we have 1, we have 2, we have 3, we have 4, 5, and we have 6. And don't forget we have y here, and we have y. I have 3, 5, 17, and then I have 95, 173, and then I have the last but not the least, which is 285. So then I have the difference of y, and then I have the difference square y, and therefore I have the difference cube of y. So as you can see, those values of x, see them, you can see from 0 to 6, and also the values of this y, you can see from the table from 3, 5, 17, and 45, and 95. So how can we find dy and this d square y, and therefore this del cube y? The first thing that you are going to do, you have to subtract 5 and 2, got 2. Also subtract 17 minus 5, you will got 12, and also 45 minus 17, you got 28, and also 95 minus 45 will get what? 50. Also 173 minus 95, I'll get 78. Also 285 minus 173, so I'll get 112. So also I'll say 12 minus this, I'll get 10. Also this minus this, I'll get 16. Also this minus this, I'll get 22. Also 78 minus this, I'll get 28. Also this minus this, I'll get 34. And also this minus this, I'll got 6. This minus this, I'll got 6. So then I'll say this will be 0, 0, 0. Someone might ask, why did I put 0, 0, and 0? The reason is that this is polynomial, and whenever if I add d power 4 of y here, so at the end if I subtract this and this, I must get 0. So since I will get 0, so there is no need of subtracting all this. So I hope you get it. So the next thing that you are going to know is that the general form for the polynomial, it is what? It is f of x, which is the same thing as ax to the power of what? To the power of 3, x to the power of what? Of 3, and also plus bx squared plus cx plus what? Plus d. So this is the general form of what? Of the polynomial. So the next thing that you are going to do, we can use the forward difference formula for what? For a polynomial. So how can we use the formula? But before then, you have to take note that from what it says, hence find the f of what? F of 4 from the obtained polynomials and compare to that table. So as you all know, the fourth, which is 95. So you have to take note of this, and don't forget to write all this difference that I already write here, because I'm going to delete it and we are going to continue with our solving. So the forward difference formula for the polynomial is what? F of x, it is the same thing as what? As f of 0, and also plus x of this f of 0 plus x by 2 factorial, and we have f of 0 plus, we have x here, x minus 1, and also we have x minus 2, x minus 2 divided by 3 factorial up to infinity. So from our table, if you could record from the table, f of 0, it is the same thing as 3, and therefore the df of what? Of 0, it is the same thing as 2, And also the d square of what of this f of 0, it is the same thing as 10, and therefore the d power 3 of f of 0, it is the same thing as what, and at 6. If you could recall, the values that we are putting here is that, if you could recall from what, from the table that I drew, we have numbers in straights. We have 0, we have 3, we have 2, we have 10, and we have 6. So those are the numbers that we insert. We insert 3, we insert 2, we insert 10, and we insert what? 6. So you have to take note of that. Those numbers that I wrote, f of 0 and the f of 0 and d square f of 0 and d cube f of what? F of 0. So you have to take note of where did I find those values of 3, 2, 10, and what? And 6. So therefore I'm going to substitute those f of 0, df, and those 4 values that I put, which is 3, 2, 10, and what, and 6. So I'm going to substitute them in what? In this formula that I write. So the f of x should now be equals to the f of 0. If you could recall, if you take the naught, it is 3. So 3 plus x, I will have x, and the f of 0 also, it is what? It is 2, and therefore plus x, don't forget I have x minus what? Minus 1, and multiplied by what? By d square, which is what? Which is the d square f of 0, which is 10. And then don't forget I have 2 factorial, and 2 factorial is the same thing as what? As 2. So then I have to say plus this, so I have to substitute. So therefore I will say x into what? Into x minus 1, and therefore I will say x minus what? Minus 2 multiplied by 6, and then I have to divide it by what? Because d cube of f of 0, so this is the d cube, this is the d cube f of 0, and then I have to divide by the 3 factorial, which is what? Which is 6. So you have to wait and see how can I simplify this. So therefore this f of x should now be equals to, as you can see, I will have 3. If I say 2 multiplied by this x, I'll end with only 2x, and then I have to say plus. So this 2 will go in 10 divided by 2, it will give me 5. And don't forget, if I say x multiplied by x, I'll get x squared, and if I say x multiplied by 1, and I'll get what? X. And don't forget I have 5. So this is the same thing as saying I have 5x, and also I have x minus what? 1. So therefore I will say this is 5x squared minus what? Minus 5x. So if I should factor out, I will say, let me say 5 outside, and I will say x squared minus what? Minus x. So I can factor it. So therefore I will say 5 into what? X squared, and therefore I will say minus x, and therefore plus what? Plus x squared minus x, and also x squared minus what? Minus x, and also x what? X minus 2. Yeah, I hope you get it. So as you can see from here, this 6 will go with this 6. This multiplied by this, I'll get x squared, and therefore this multiplied by this, I'll get x. X times 1, I'll get only x, and therefore I'll keep down this x minus 2. So you have to take note of that. So the next thing I have to say, this will be equal to, my 3 is there, and also 2x is there. So I have to expand this bracket, and I will have 5x squared minus what? Minus 5x plus, I have to say this times this, I'll get x to the power of 3. This times this, I'll get 2x squared. So minus 2x squared. This multiplied by this, I'll get negative x squared. So minus what? X squared. And this multiplied by this, I'll get positive 2x. So I'll now say plus 2x. Yeah, so this is the same thing as saying I have 3x plus 2x plus 5x squared minus 5x plus I will say x cubed, this and this. If I add them, I'll get negative what? 3x squared. 3x squared plus what? Plus 2x. So the next thing that I'm going to do, I have to go through the like terms. The first thing that I'm going to do, I have this x cubed. So it has the highest power. So I'll first keep it down because I'm going to arrange it. Don't forget, I have 5x squared here, and also I have 3x squared. So I have to factor them. So this is the same as saying plus what? Open bracket 5 minus what? Minus 3. And therefore multiplied by this x squared. Because if you said this multiplied by what? By 5, at the end you get x squared 5, and this multiplied by this negative 3x, at the end you'll get negative 3x squared. So I hope you get what I do. So the next thing that I'm going to do here is that if you are confused, you can pause the video and try it yourself. So the next thing I'm going through for the x, but okay, but there is one thing that I need you to know. I think we don't have x here. There is no x here, it is only 3. Please, I'm sorry for that, it is only 3. I just noticed it now. So therefore I have to say, for those that has only x, I have 2x, and also I have this 2x, I have 5x. There are the one that has only x, so I'll start with the 2, positive 2, and 5, which is what? I have to say the 5, it is negative. So minus 5, the 2 is positive. I have to say plus what? Plus 2, and therefore I will say x. What next? The next is the 3, so I have to say plus 3. So the next thing that I'm going to do here is that I have x cubed, so I will say this x cubed plus what? For x squared, 5 minus 3 is the same thing as 2, so I will say 2x squared, and also I will say 2 minus 3, it is okay, sorry, 2 minus 5, it is the same thing as minus 3. Minus 3 plus 2, it is the same thing as negative 1, which is negative x. If you multiply negative 1 by x, so then I have to say plus this 3. So the next thing, I will use the polynomial. That formula that I wrote before, I'm going to use it, which says, I think, f of x, if I shouldn't forget it, x, ax of cube, I think, yes, plus bx squared plus cx and also plus d. So the next thing that I'm going to say, I have to say, instead of f of x, I will say f of 4, because it says hence f of 4 from the polynomials compare to what? To that table. So I will say this is equals, as you can see, this, it is almost the same thing as this. So I have to substitute the value of what? 4 in this x. So I will now say 4 power 3 plus 2 4 squared, and also minus 4 plus what? Plus 3. So what should I going to get? So at the end, I'll get what? 95. So wow, as you can see, also from the table in this 4, it is. Find a root of the equation x cubed minus 5x plus 3, it is equal to 0, using the Newton-Raphson method. Correct to 3 decimal places. In the interval, we are given 0 and 1 with an initial guess of what? x0, which is x0 is the same thing as 0.8. So we are going to write the formula for the Newton-Raphson. So the Newton-Raphson formula, which is x of n plus 1, it is the same thing as x of n minus the function of what? Of x of n divided by the derivative of h. So which is the f prime of what? The f prime of x of what? X of n. So I'm going to say the function, which is the f of x, it is the same thing as x cubed minus what? Minus 5x plus what? Plus 3. So the next thing that I'm going to do, I have to find the derivative. The derivative, let me call this as what? As my first equation. What will be the derivative of what? Of this function. So x cubed. X cubed, to differentiate it, I will get 3x what? X squared, and therefore minus the derivative of 5x, which is 5, derivative of constant, it is 0. So let me call this equation 1, equation 2. So I have to substitute equation 1 and equation 2. So therefore I will say the x of n plus what? Plus 1 will now be equals to, I'll have the x of what? X of n. So the f of x, this is the numerator, it will now be equals to x, let's say the power of 3, and then I'll put the subscript of n, and then I'll say 5x of what? Of n plus what? Plus 3, also divided by the what? By the f prime, which is the denominator, which is this function. So I'm going to substitute it. I'll say 3x what? 3x squared, subscript of what? Of n, subtract by what? Subtract by 5. So now we are going to perform the iteration when n it is equals to 0 from the equation, from the question that we are given x naught. So we are going to perform our what? Our iteration. So I need some space. So now the first thing that I'm going to do, I have to say when n it is equals to, when n it is equals to 0, and therefore from our question x naught, it is the same thing as what? As 0. What? 0.8. So I'm going to say x what? Since x n it is 0, so 0 plus 1, it is the same thing as that 1. So therefore I'm going to what? I'm going to substitute the value of n in what? In this equation. But I'm sorry, I have what? This, I have negative sign. Please, sorry, I have negative. This is negative. So therefore I have to say what is the xn. Xn, it is the same thing as what? As 0.8, as is given from the question. So I have to say minus, also this is x of n. So therefore I have to put it in bracket 0.8 cube minus what? Minus 5 multiplied by what? Xn. Xn, which is what? Which is 0. What? And 0.8, and xn, it is the same thing as what? X naught, and x naught, it is 0.8, guys. So I have to say plus what? Plus 3, and then I have to divide it by what? Divided by 3, also multiplied by 0.8 squared minus what? Minus 5. At the end, my new x1, let me see, what should I going to get? Divided by, so guys, I'll get 0.64156 as what? As the value of x1. So now I'm going to say when n it is equals to 1, but I need some space. So I have to say when n it is equals to 1. So the equation will now become, since n it is equals to 1, if I substitute the subscript of x of n plus 1, I have to say 1 plus 1. So this will now become x2, which will be equals to the value of what? Of x2. Okay, sorry, the value of x1. This is x1. So therefore I will say 0.64156 what? 56 minus also the 0.641 what? 56, let's say the power of what? Of 3 minus what? Minus 5. This is 5, and also 0.641 what? 56, and also I will say plus what? Plus 3, and divide it by 3 multiplied by 0.6415 what? 56 squared minus 5. So I will say minus 5. So I have to get it. So therefore let me see, what should I going to get? So at the end I will get 0.65645. So therefore now I'm going to say for when n it is equals, so this is what, this is x2. Now I'm going to say when n it is equals to 2. So now when n it is equals to 2, the equation will now become, so if I add 2 plus 1, I'll get 30. So this will now become x30. So my x2, this is x2. So I would say 0. What? 0.65645. I have to subtract it by 0. The same thing, which is the x2 5645. I have to put the power of 30, and therefore minus 5, also 0.65645, and I have to add 30 plus 30 and divide it also by 30 multiplied by what? Multiplied by 0. Also 6564 squared minus 5. So therefore at the end my x30 should now be equals to, let me see what we are going to get. So this is 0. What? 0.65663 as what? As my x3. So therefore the value of x2 and x3, which is equals to the value of x2, it is this, which is 0.65645, and also the value of x3, which is 0.5663. They are both approximately equals to what? I can say all of them, they can be approximately equals to 0.657. Yes, this can be approximately equals to 0.657, and also this can be approximately equals to 0.667. So when I rounded it off to 3 decimal places, the process has what? Has converged. So therefore this is end of what? Of this question to what? To 3 decimal places. Newton-Raphson formula for the qth root to derive the iteration formula to compute the qth root of a number m, and then use it to evaluate what? The 5th root of 43 correct to 3 decimal places with x0 it is equals to 2. So the first thing that you are going to do when this question is given to you is that to find the qth root of a number m, I have to say let x be equals to what? Be equals to the 5th root of what? The 5th root of 43. And this can be rewrite as, if I take the 5th root of both sides, I'll have 5th root and I will have 5th root. 5th root will cancel 5th root. At the end I will left with only x raised to the power of what? X raised to the power of 5. It is equals to what? Only 40 what? 43. So therefore, and also this is implies that x raised to the power of 5 minus what? Minus 43. Minus 43 equals to what? Equals to 0. When this positive 43 would cross that equal sign, it will become negative, and therefore I will equate it as what? As 0. The function f of x should now be x power 5 and also minus what? Minus 43. And therefore I'll find the f prime, which is the derivative of what? Of the function. If I differentiate x raised to the power of 5, I'll get 5x power 4. But if I differentiate 43, derivative of constant is 0. So the formula for what? For the Raphson, for the Newton-Raphson method is what? It says x of n plus what? Plus 1. It is the same thing as, it is equals to x of n minus what? Minus f of xn, and also divided by f prime of what? Of xn. This is prime. and therefore this will now be equals to the x of what, of n, minus the f of x of n, which is the first function, which is x raised to the power of 5 minus what, minus 43, and also I will divide it by the derivative that I differentiate, which is the f prime of what, f prime of x, which is raised to the power of 4, and what, and I have what, I have n. So therefore the x of n plus 1 should now be equals to, all the way, this is the same thing as divided by 1, I have the LCM, which is also 5, which is 5x raised to the power of 4 as a subscript of n. So if I set this into 1, it will give me the same thing, which is that 5x power 4 of n. So I have to multiply it with what? With this 5x of n. So therefore, if I multiply it, I'll get 5x what? 5x raised to the power of 5 of what? Of n, and then I have to say subtracted by. If I set this into this, I'll get 1. So therefore, if I subtract 1 by the what? By this, I'll get only this. That's the power of what? Of 5 with the subscript of n minus 43. And this is the same thing as, because they have the same power, so I can easily subtract. So as soon as if I subtract them, I'll get what? I will get 4x power 5 as the subscript of n, and then, sorry, this I have to put it in bracket. I have to say minus, sorry, this is in bracket, and therefore when you distribute, this will not change, it will become positive. So this will now become positive what? Positive 43 divided by what? Divided by 5x power 4 of what? Of n. So therefore, the next thing that we are going to do, we are going to find the iteration, first iteration, second iteration, afterward, after the point that we will have the same when two iterations are equal. So therefore, I will say, let's say first iteration, let me say iteration 1, but when n it is what? When n it is equals to what? 0. And also from the question they give us when x naught it is equals to 2, this is 8. So therefore from the first iteration, when n it is equals to 0, so therefore 0 plus 1 it is 1. So therefore I will say x what? x1 it is equals to what? I will say 4, but when x it is equals to 2 from the question, so I will now say raised to the power of what? Of 5, and therefore plus 43, and also divided by 5 multiplied by what? By 2, also to the power of what? To the power of 4. So let me see what shall I going to get. So therefore at the end I'll get 2.137 what? 75 as what? As my value of x1. So therefore I will move to second iteration. So let me say, but in iteration 2, n should now become 1, because iteration 1 n is 0. So therefore I will now say x2 it is the same thing as 4 multiplied by this 2.1375 raised to the power of what? Raised to the power of 5, and therefore plus what? Plus 43 divided by what? Divided by 5 multiplied by 2.1375 raised to the power of what? Of 4. So let me see what should I going to get. So at the end I'll get 2.206 what? 65 as what? As my second iteration. So therefore I am moving to iteration 3. So moving to third iteration, when what? When n it is equals to, so moving to the third iteration when n it is what? It is equals to 2. and our x2 is this. So therefore it will now become x3. Let me say x3. It is the same thing as 4 multiplied by 2.2065 raised to the power of 5, also plus 43, and divided by 5 multiplied by 2.2065 raised to the power of what? Raised to the power of 4. So let me see what we are going to get. So at the end, I'll get 2.1234. So let me move to the fourth iteration. But in fourth, okay, let me say, yes, fourth iteration. In fourth iteration, I will say when n it is equals to what? It is equals to 30. So let me say when n it is equals to 30. So it will now become x4. So x4 will now be 4 multiplied by 2.1234 power 5 plus 43 divided by what? By 5 multiplied by 2.1234 raised to the power of what? Power 4. Again, what should I going to get? The value of x4, which is 2.1218. Yes, I think it's 8. Yes, approximately. But don't forget, this is n3 when n it is equals to what? When n it is equals to 30. So now we are going to perform the fifth iteration, iteration 5. So from iteration 5, when n it is equals to 4, when n it is equals to 4, iteration what? Iteration 5. So therefore this should now be the x of what? X of 5, it is equals to 4 multiplied by 2.1218 raised to the power of 5 plus what? Plus 43 divided by what? 5 multiplied by 2.1218 raised to the power of what? Of 4. What should I going to get? So this is the same thing as 2.1217 what? 75. So therefore, as you can see, both x4 and x5 are equal to what? Are equal to, both the x and 5 are equal to 2.122 approximately, because this is my x4. If I approximate it to 3 decimal places, I'll get 2.1 point what? 0.1, and also this 8 will add 1 to this one and it will become 2, and also this 7 will add 1 to this 2, it will become 2.1 what? 122. The next thing that you are going to know is that whenever, if you press in calculator and says what will be the what? What will be the fifth of 43? The fifth root of this 43 to 3 decimal places, so you will automatically get 2.122. If you round it off to what? To 3 decimal places, you get 2.122, and also we get 2.122 in our iteration. So therefore, this is what? This is a solution of what? Of this Newton-Raphson formula for the cubed root. Prove the identity. Forward difference cube, it is equals to e cubed minus 3e squared plus 3e minus what? Minus 1. As we all know, the forward difference operator, which is this del, it is the same thing as what? As e minus what? Minus 1. So therefore, to find d cube, to find this forward difference cube, I can expand what? I can expand the expression of what? I can say this is the same thing as what? Or let me say, so that you will understand it, let me say this will implies the power difference. It is the same thing as what? It is the same thing as e minus what? Minus 1 cube. So therefore, as you all know, e minus 1 cube, it is the same thing as what? It is the same thing as e cube minus what? Minus 3e what? 3e squared multiplied by what? By 1, and also plus what? Plus 3e, and also multiplied by what? Multiplied by 1 square minus 1 raised to the power of what? Raised to the power of 3. So therefore, the difference, the 4 difference cube, it is the same thing as e to the power of 3 multiplied by this. This is e to the power of 3. I keep it down, and therefore I have to say subtract it by 3e what? E squared when I multiply this, and also I multiply with this one. So therefore I have to say plus what? Plus 3 multiplied by this e, and therefore multiplied by this 1 squared. Also I will get only 3e, and also 1 cube is the same thing as that 1. So as you can see, this forward difference operator, it is the same thing as this. It's been proved. But there's one thing that I need you to know. I said e minus 1 cube, I say it is the same thing as what? As this. Some people might say how? So I have to say e1 minus 1 and e minus 1, not e1, and therefore e minus what? 1. So I have to multiply them. So I have to say, the first thing that I'm going to do, let me keep this e1 minus 1 first, and this multiplied by this, I'll get what? E squared, and therefore this multiplied by this, I'll get only what? Negative e, and therefore 1 multiplied by this, I'll get negative e. So I'll have negative e. 1 multiplied by this, I'll get positive what? Positive e. So okay, sorry, positive 1. So as you can see, I've done with what? With that. So this is the same thing as saying it will now become e squared minus e minus e. I'll get minus 2e plus what? Plus 1. So I'll multiply it by this e minus what? By this e minus 1. I'll multiply by this e squared minus 2e plus 1. So I'm going to multiply this e multiplied by this e. I'll get what? I'll get e cube, and therefore this e multiplied by this, I'll get what? And I'll get minus, yes, I'll get minus 2e squared. Yeah, and therefore the same thing, e multiplied by 1, I'll get plus what? Yeah, I'll get plus e, plus only e, and then 1 multiplied by this e squared, and I will get negative what? E squared, and also 1 multiplied by this negative 2e. What should I going to get? I'll get negative what? Negative, okay, this negative multiplied by this negative, I'll get positive 2 what? 2e, and also this negative 1 multiplied by this positive 1, I'll get negative 1. So at the end, as you can see, it will be e cube, and then I will say this e squared and this squared, they are in common. So if I say minus 2e squared minus e squared, it is the same thing as minus 3e squared. So minus 3e what? Minus 3e squared. And therefore I'm done with it. I'm done with this. I'm done with this. So let's come for e. E plus 2e, I'll get positive, yeah, positive what? Positive 3e, positive 3e, and therefore I have what? I have only 1, which is negative 1. So as you can see, I have what? I have e to the 3rd power minus 3e squared, and also plus 3e minus what? Minus 1, and it is the same thing as what I write here, and it is the same thing as this equal sign of what? Of this question. So therefore, hence this identity is being proved. A second degree polynomial passes through the points 0, 1, 1, 3, 2, 7. So we are to find the polynomial. So the first thing that you are going to do, guys, is that don't forget we have x and we have f of what? F of x, and we have the f of x, and we have d square f of what? F of x. You have to take note of this. And therefore we have 0, 1. This 0, 1. So you now say I have 0, I have 1 here. Done with that. And then this 1, 3, I have 1 and 3. So you now keep it 1. You have 1 here and you have 3 here. And 2 and 7. You now keep it. I have 2 here. I have 7 here. After then 3 minus 1, you get 2. So you have to insert the 2 somewhere around here. Then 7 minus 3, you get 4. So you now put your 4 here. After then, come to d square f of x. This 4 minus 2, it will give you 2. So inside your 2 here. The next thing, as you can see, we have something like this. So I'm going to use this. So at this point, this f of 0, it is the same thing as 1, which is this. And therefore, this f of what? This, okay, sorry, it is the f. It is the f of 0. It is the same thing as this first 2. And also the square f of what? F of 0. Or let's say x naught or something s. I can say let's say f of what? F of x naught or something. But you can write the f of x naught. Even me too, let me change it. Let me change it as x naught. X naught. X naught. So also this is what? Is 2. So the next thing that I'm going to do, I have to substitute using the formula, but I'm just going to put the formula. But before then, I need some space. So therefore, the f of what? The f of x, it is the same thing as what? 1 plus what? Plus x multiplied by what? By 2. So I'm just substituting it direct because I know you know the formula, but let me write the formula for you so that you will not be confused. So the f of x, it is the same thing as the first we have f of x naught plus x d of y naught, and also plus x, which is x minus 1 divided by 2 factorial, and also multiplied by this d square y naught of to infinity. So I'll say this will be equals to, what will be our f of x naught, which is 1. So I'll say 1. So I'll now say 1 and then plus what? Plus this x. I have x here and I have d change, which is dy naught. My dy naught, it is what? It is 2. This is 8. So I'll now say 2 plus, I have x here. I have x minus 1 divided by 2 factorial is the same thing as 2, and therefore I have d square y naught, which is this. So therefore I will say multiplied by 2. But don't forget, this 2 will go with this 2. At the end, I'll have something like this. My new f of x should now be equals to 1 plus 2 multiplied by x, which is 2x, and therefore plus, if I said x times x squared, x times 1, it will give me x. So I will now say x squared minus what? Minus x. So therefore this should now be equals to, so I have to arrange them. The f of x should now be equals to, I'll have something like this. I'll have x squared and I'll say plus what? Plus x, this, and what? and this, it will now become only 1x. So therefore x plus what? Plus 1. So therefore this is the final what? This is the final solution to this question. Find a real root of the equation solved. 2x minus log 10 of x, it is equals to 7. Use fixed point iteration. Take the x0, which is x0 at 3.0. Then determine the root by the Aikins d square method. So we are going to do two things here. We are going to first find the real root of this equation, but before that I am going to first define my function. I will say my function f of x will now be equals to 2x. I have 2x minus log of 10 of x. It is the same thing as what? As 7. So you have to take note. If I say 2x minus log of what? Log of 10 of x, it is equals to 7. When this log of 10 of x cross the equal sign, so I'll have 2x, which is equals to 7 plus what? Plus log of what? Log of 10 of x, and then I'll divide both sides by 2. Divide both sides by 2. 2 will go with 2. At the end, x should now be equals to 7 plus what? Log of what? Log of 10 of what? Of x, and also divide it by what? Divided by 2. So I'm going to use this. So therefore I will say x will be equals to, let me say g of x will now be equals to, as I said, 7 plus what? X. Okay, sorry, log 10 of x, and also divided by what? Divide it by 2. So the next thing that I'm going to do here is that, as I'm given x0, it is the same thing as x0, which is 3.00. So let me say 3.8 what? 00345. So this is my what? This is my x0. So then I will say the x of n plus what? Plus 1 will be equals to g of x of what? G of x of n. It is the same thing as 7 plus what will be the log of what? Log of x of n. This it will be with n. Log of x of n. So I have to say, if I press in my calculator and say log of base 10 with 3.80000, what should I going to get? Point. So at the end I will get 0.5797835969 off to what? Off to infinity. So the next thing that I'm going to do here is that, let me clean this. I have to clean this. So at this stage, my n, it is equals to 0. So therefore this x of what? X of n plus 1. But before then I have to say log of what? Log of 10 x of what? X of n, and also divided by what? Divided by 2. So this is my x0, and after then I find the solution of log of xn. So therefore the solution of this, let me say the log of x base 10 of log of xn, it will be what? It will be 0.5797 as I write it before. So therefore as n it is equals to 0, so 1 plus 0, it is the same thing as 1. So I'll have x1, I'll say 7 plus what? Plus 0.5 what? 5798, and I'll have 35969. I have to divide it by what? By 2. So the next thing that I'm going to do is that, let me divide this. So at the end I'll get what? 3.789891792. 830 what 05. So I'll only carry 3.7900. so I'll just carry only this value. So the next thing that I'm going to do is I have to say this, the final solution of this that I already find, so I have to multiply it with what? With log of x1. So what is the log of x1? If I multiplied it with log of x1, at the end I'll get what? What is my x1? This is my x1. So if I multiply it, I will say it will now be equals to so at the end it will be 0.5 also less 7962761. This is 276100543 what 67. So the next thing that I'm going to do, I have to say x2, my x2 will now be equals to what? Will now be equals to 7 plus what? Plus this 0.579. So as you can see, before, if we are dealing with another x, so now I will say 7 plus what? I will not say 7 plus exactly this thing. So because the final result that I find here, so I'm going to multiply it by what? By log of x of n. And you have to take note, x it is increasing. So this, before I did it with 0 with x naught, which is that 3.8. So you have to take note, first for this x of n, I did it with what? With 0. I multiplied log of what? Log of 10 by 3.80000 until I get what? I get this 0.5379 and what? And those things. So after then, the final solution that I get after this, so then I will make this to what? To 4 significant figure. So after making it to 4 significant figure, so this will be my new x1. So after then I will say this multiplied by log of what? Log of this. I hope you get it. So now I am going to say the final answer that I get for, if I said this multiplied by the log of this, let me see what I get. Yes, I get 0.5796 divided by 2. So after then, let me see what should I going to get. Let me see what should I going to get. 7 plus answer divided by 2. So I will get again, which is 3.78931305502718. I will leave it correct to 4 decimal places, 3.7893. So the next thing that I'm going to do, I will now say this x2, I'm going to say this final solution that I got, so I'm going to multiply it by what? By this log of this x2. So I'll say this for my answer, which is 3 multiplied by the log of 3.78. So at the end, the same thing, I will get 0.5796262703974. So therefore my x3 should now be 7 plus, then I'm going to use this. The essence of finding this is that you are going to use it as your new log of x of n, whereby the x of n, this x of n, it is increasing with 0, 1, 2, up to what? Up to the time that you will realize that you have the same values. So therefore I will say 0.59, okay, 79 up to what? Up to this 4. So you have to take note that I just leave it so that it will go straight forward to what we are looking for. I write the complete this here, so I have to divide it by 2. So this will now be equals to, so I got 3.78928026313511987. So I'll leave it correct to 3.7893. So as you can see, this x2 and x3 are what? They are the same. So now the question says I'm to find the real root of this equation, and I will use this fixed point iteration. So I've already done with that. So I got this 3.7893. So since they are the same, so I'm going to leave it like this. And then the next is that the question says then determine the root by the Aikens d square method. So now I'm going to use the Aikens d square method in order to what? In order to determine the what? The roots. So you have to take note of that. Whenever if you realize that the two of x out are the same, as you can see, x2 and x3 they are the same, so you are going to leave it like this. So by using the Aikens d square method, I have to take note of the value of x0, which is what? Let me say 3.8. Let me add 9, at least 9 zeros, and the value of x1. If you can recall, our value of x1, it is what? It is 3.7898 something else. That long numbers that we find. So let me say it is approximately only 3.78 times what? Times 10 to the power of what? Of 13. And I have to say what will be the value of x2. From the solution, we find our value of x2 at 3.7 what? At 3.7893. Let me check the calculator history. Yes, I got 3.78931340. So let me leave it approximately times what? Times 10 to the power of what? To the power of 14. So the next thing that I'm going to do, I have to find the dx0, because from the Aikens d square process we have dx0 and we have d square naught. So we are going to find each of them. So this will now be equals to x. It is x1, it is formula which is x1 minus x0. So d of x0, it is x1 minus x0. And you have to take note of this. We have x1 and we have x0. So no need of writing it, but you have to say this minus this. So what are we going to get? So at the end, my dx1, my dx0 will be negative 0.0101082016915995, and then I'm going to find dx1. This is not, you have to take note of that. It is equals to x2 minus x1. So I will say x2 minus x1. What should I going to get? So my dx1, it is equals to negative 0.005783928056866. So the next thing I'm going to find the d square x naught, and it is the same thing as d of x1 that we find and minus d of x naught also that we find. So you have to take note of this, and also take note of this in Aitken's d square method, or let me say process, and you have to take note of this also. So let me see this, the answer dx1, this is minus. So my d of x, d square x naught, it is the same thing as 0.00952980888590884. I hope you get it. So the next thing that I'm going to do now, I'm going to use this value of dx naught and the value of dx1 and the value of d square x naught. So you have to write it down. Feel free to pause the video and write all of them. So I hope you write it down. So the formula of the Aitken's d square process, it is the same thing as what? As x, it is the same thing as the value of x naught minus what? Minus dx naught squared divided by d square x what? X naught. So this will now be our x naught, as you all know, 3.8 times 10 to the power of 9, which is the same thing as, okay, sorry, I have to multiply it. Okay, I have to say it is subtraction according to the formula, minus the value of this dx what? Value of this dx naught, because this is dx naught, it is minus 0.010108201691595 in squared, and divide it by d square x naught, which is 0.095298888590884. This is 9. So at the end, let me see what should I going to get finally. 3.8 times 24 minus fraction minus 0.010821695 squared divided by 0.095298888859084. So I'll get 3.7892821585521. So this is the final solution of what? Of this question. Finite difference operator. Compute a d square e to the power of what? Of x. So I have to first say the d of f of what? Of x, it is the same thing as what? As f of x plus what? Plus h minus what? Minus f of x. So I have to let this the f of x, let me let f of x to be the e to the power of x, which is this, and the d square, it will now be, let me say, before d square I have to say the d, which is d of x, it is the same thing as you can see, d of x plus what? Plus 4 minus e of what? E of x, and therefore I have to say it will be equals to 1. So what should I going to get? So as you can see, if I factor out, it is the same thing as saying e to the power of x outside, and then e to the power of what? Of h, then subtract it by what? By 1. This multiplied by this, it will give you what? This, and this multiplied by this, it will give you this. I hope you get it. So the next thing that I'm going to do here is that, and the reason why I put this is that from the formula it says d of f of x, so this is my f of x, this e to the power of x, so I say d and the f of x, and this e to the power of x plus h, I find it through my f of x plus h. from the formula f of x plus h. So I'll just put the e and I'll put the power of x plus h, and then minus f of x. This is my f of x. So the next thing that I'm going to do is that I'm looking for what? I'm looking for d square e to the power of x. So I will now say d square e to the power of what? Of x. It is equals to, I have to say the d by what? By d of x. It is the same thing as what? I will say d of what? What is the value of d of x? This value, we already find it, which is this. So I'm going to say e to the what? E to the x multiplied by what? E to the h minus 1. E to the h minus 1. You don't have to be confused because I'm just putting what? This value of d e to the power of x. So the next thing that I'm going to do, because e to the power of h minus 1 is constant, so with respect to x, I will say that d square e to the power of x, it will be equals to the e to the h minus 1 and multiplied by d e to the what? E to the x, and hence this e to the h minus what? Minus 1, it will now be equals to multiplied by the d to the x, which is this. So I will say e to the x multiplied by e to the h minus what? Minus 1. So now this will be equals to, since e to the h minus 1, e to the h minus 1 are twice, so I can say this e to the x multiplied by e to the h minus 1 whole what? Whole squared. So therefore at the end, e square e to the x, it is the same thing as e to the x into e to the h minus what? Minus 1 square. But you have to take note of this for what? For h is equals to 1, so this is what? This is e to the x of e to the what? Negative 1 squared. So this is the end. Construct a forward difference table for y. It is equals to this function at x. It is equals to 1, 2, 3, and what? And 4. So as you all know, I'm going to compute y for each x. You have to take note when x it is equals to 1, and when x it is equals to 2, when x it is 3, when x it is 4, and when x it is what? It is 5. My y should now be, if I substitute x it is equals to 1 in this function, what should I going to get? So I'll get 4. And also if I substitute what? Substitute 2 inside this function, I'll get y it is equals to 13. And also if I substitute 3, I'll got 34. And if I substitute 4 and also y, I'll got 73. If I substitute 5, the last but not least, you have to take note, these are the x. You are going to substitute them. So I'll got 136. I have to find my first forward difference because this is forward difference table. Construct a forward difference table, so we are going to construct it. So to construct it, we are going to first find the first forward difference, second forward difference, and third forward difference. So let me say this, the first forward difference, which is say dy, it is equals to what? It will be equals to y of I plus 1 minus what? Minus y of what? Y of I. So I have to find the y1, which is the same thing as this 13 minus 4. So I will say 13 minus 4, it is equals to 9. And dy2, it is equals to what? It is equals to 34 minus 13. So 34 minus 13, it is equals to 21. And dy3, it is 73 minus 34. So I will say 73 minus 34, it will now be equals to 39. And therefore dy of what? Of 4, it will be 136 minus 73. So 136 minus 73, it is equals to 63. So I'm going for the what? This is for the first forward difference, so I'm going for the second forward difference. For the second forward difference, this is the same thing as d square y. It is the same thing as dy I plus 1 minus dy I. So how can I subtract this? The first thing that I'm going to do here is that I have to say d square y1, it is the same thing as this minus this. So I'll now say 21 minus 9, it will be equals to what? So it will be 12. And therefore, for the d square y2, it is the same thing as saying 39, which is this 39 minus 21. So I'll got minus 21, I'll got 18. And then I will have d cube y3. Okay, sorry, d square y3, it is the same thing as this minus this, which is 63 minus what? Minus 39. So I'll get 24. And then I'm going to find the third difference. So what will be the third difference, which is d cube y, it is the same thing as d square yi plus 1, this is I plus 1, minus what? Minus d square yi. So I'll say this minus what? Minus this. I'll say d cube of y1, it is the same thing as 18 minus 18 minus 12, I'll got 6. And the third of y2, it will be 24 minus 18, 24 minus 18, and I'll get what? I'll get 6 also. So the table will now be, I will have x, I will have y, and I will have this dy, I will have d square y, I will have d cube y. For x, don't forget I have 1, 2, 3, 4, and what? And 5. And for the value of y, don't forget my substitution. I substitute x, it is equals to 1, I get 4, and also I get 13 for x equals to 2, I get 34 for x equals to 3, I get 73 for x equals to 4, I get 136 for x equals to 5. So I'll subtract this and this, I'll get 9, this and this, I'll get 21, this and this, I'll get 39, this and this, I'll get 63. Also this and this, subtract 21 and 9, I'll have what? I'll have 12, and therefore subtract this and this, I'll get 18, subtract this and this, I'll get 24. The same thing, subtract this and this, I'll get 6, subtract this and this, I'll get 6 also. So as you can see, this is our